Yes, last time we was soldering most of the components. We were soldering the ship sockets. We encountered some problems. We solved some of them. Some of them we didn't solve. But anyway, the next part of this build is anyway to populate the sockets and start to test out this thing. We see how far we get in this video. I have some traveling ahead, so I'm not sure how much time I will have to work on this in this video, so it might be another part before we can start testing this for real. To help with the placement of the chips, I told you about in the first episode that every one of these chips here is Russian chips, and I actually found this diagram with the Russian names and the socket placement. There are some differences between the naming of the chips and the actual list here, but I also have this as a backup. And even though this print is not very good, on the original picture I can make out what some of these chips are. And this is not the exact same board that I have. And I can see they have made some changes over here. Probably the tape interface and stuff. And they have not made the same layout for the keyboard interface. But the rest of the schematics looks the same. So now we are going just to start and put in the chips. And I have to say that this is the original chip and the original material that is coming. While this is good for shipping so that you don't break anything and don't bend the legs on the chips, this is a terrible packing material to enhance the life of these chips. Every old ship that is shipped deserves to use this kind of packing material. It don't look much different, but this shipping material actually has some conductive foam, so when you put a chip in this, it's also safe from bending the legs. But all the chip's legs are connected together with this high resistant foam, and that makes a huge difference to avoid these old fragile chips being destroyed by static electricity. But now I'm just starting to populate the board. There will be maybe some small comments along the way, but I might speed up the process as I go along with this. My method for making these legs fit is that I bend one side of the chips, put this inside and just fit it like so. It might not look it, but I'm actually quite secure when it comes to the anti-static matter. I'm using waistband anti-static connection, and this clout here is connected with ground, and the same with this, and all the other equipment here is also grounded to the same level of ground. And I will make another video in the not too distant future about the importance of keeping old electronics safe from static discharge, because this is a problem that I feel like there is not many YouTubers who take seriously enough. And I can't I can't even count how many times I've heard the expression, but I've never encountered any damage due to static electricity and so on. But that's just a sign of ignorance, because often you won't notice the effects of a static discharge before long time in the future, and often when you have intermittent temperature failure inside chips, it's caused by earlier static electric discharge faults. Every one of these chips actually start with K555, and that's, I know it sounds like an American telephone number from a movie, but that was actually what the Russians was calling their 74 series of logic. So they start with 555, and we have some other logic chips that start with other. Here is a K561, but most of these is 555. Some of these chips actually have quite a strange fit. Normally when you have these legs like this, the gap between the bottom of the chip and where this narrow part of this leg begin, it's almost online. But these Russian chips have another philosophy, because this is going much further down, so the chips actually don't fit very good into the sockets, at least not the high quality sockets with good rounded and good fastening around the legs, because this extends much further down. It's actually more than a millimeter to the end of this. But that's only an aesthetic problem, because it won't affect the function in any way. Actually, if you think about this as from the life expectancy of the chips, that the chip sits higher up means that you have airflow around the chip. You can see it again that these legs is quite long, so they also bottom out into the bottom of the sockets. But I won't bother with that for now. I will just fit them as best as I can. Yes, so what do we know? We have one ship left, and I can't find this in the part list. It's the one that I said that stated as a 561. This might be a fix. Maybe this is meant to replace those ships up in the tape interface. I don't know, but that I will have to find out. So the first thing I need to do now is actually identify what this ship really is. To find the equivalents of these old Russian ships, it can be quite the challenge. You have to be able to interpret and actually write these Russian letters, but after some digging, and I've already found the result when I found this table, but this is actually quite useful. Here you have listed the old CMOS variation of the chips. You even have some modern variants. These here, the MC series. That's in some cases is just a 1 in front of the part number, but they have some more advanced chips in that series. But what we actually found here is that the equivalent of the chip that I don't know what should be used for is an inverter. And this is the markings that will stand on the Russian chips, and we can see that this is a CD4049 A chip, and it's an 6-gate hex inverting buffer converters. So this is the CMOS equivalent of the 74 LS04 that we was talking about earlier. But I can find no reference to this in the schematics, so I will just put this aside and look further into that when we start testing of this board. So you can see still one more of the challenges regarding building something from a kit that's not well documented. I've actually dug deeper into the mystery of the extra ship, and I actually found some traces of this. This is from another seller on eBay, and they have the slightly modified version of the PCB. They have changed over here. They have put transistors instead of the unique Russian array that they had. They have also fixed this here with the diodes and the resistors that had to be connected. And up here you can see here they have one more chip that's not documented, and if you manage to read this is a K561, and you can just about read out that this is an H2 as the last letters here. There also are some other components down here, but this also has the A2 and A3 chips up here, and it also have added some extra circuitry here, probably for connecting the power supply. So this slightly modified version contains this chip, and that is a sign that they probably was digging deep into the chest and was sending me an old kind PCB, but more modern chip set, modern set of chips for this build. So the mystery deepens somewhat, but we now know that this chip has been used on these clones, at least at a time they have. They also have modified this to use only one ROM chip, but that is an available upgrade anyway, where you could use 128C128 chips instead of the 2 chips that's provided on my kit. Now we have finished up all the soldering, or most of the soldering, and we have placed the chips and most of the components. It's time to make the adapter to connect the keyboard matrix to the unit. And as we stated in the second video, the connector for the keyboard is actually a 16-pin DIL socket. So we are going to just make a cable that connects this to the keyboard unit, and I'm going to use a 16-pin socket header to solder on the leads to. I'm kind of a wild goose chase here. I'm trying to figure out where the best place to connect 5 volt power supply. And as you can see, there is no obvious place on this board, but around this capacitor will be a natural spot, because you really want a capacitor near your 5 volt input, because it will act as a reservoir for peak current that will come. And the narrower the path into the rest of the 5 volt, you more you will have to rely on the capacitors around the board, because the less peaks and the more resistance you will have to draw much 5 volt power. So I'm really not sure how to handle this the best way, but this here is 5 volt. This is the middle of the resistor network that acts as a bus transceiver here, and or a bus pull-up. I haven't really looked into it. And this is not a straight connector for this electrolytic capacitor, so it's not standing directly over the 5 volt rail. So I'm kind of at a loss of what I should do here to connect the 5 volt. This you can see here is the ground plane, and the ground is going like this up on the board, and it's quite many points here you have to connect ground. You have this spot, I've soldered this spot, and I soldered this spot as connectors. On the other side is just this spare part of this one. But as for the 5 volt, I'm really haven't found a good candidate straight on the board. Yeah, so maybe the best place is kind of in the middle of everything, and then I can just choose to use the legs of one of these decoupling capacitors that's here, because one of the sides on this is connected to ground, and that's this one, and this one is 5 volt, the 5 volt rail. So I think I will just find a place like this and just connect a wire to connect 5 volt. But I also can connect it on top here, because the top of this resistor network is also 5 volt, and that was one of the reasons that I made this before I connected this, because I want to be able to isolate this. And also this one on top is 5 volt. Yeah, so maybe I just do that, connect a wire through here. When I finished all the soldering, I just had to make a small test, so I connected everything up to my oscilloscope and this RGB converter. And my first main issue was to see if I got this RGB to HDMI unit to detect the sync signals and see if I got and see what kind of signal I was getting. There was a lot, and still are, a lot of uncertainties on this board, so I thought if this board actually gave out video output, then I would know if the oscillator circuit and most of the logic circuits was okay, because most of the logic circuits, its main purpose is to generate the screen output and divide the clocks and provide the different color signals and so on. So I thought that the quickest test I could do was to connect the video and see what kind of signals we got. And first I connected this SCART adapter, but I couldn't get anything other than a very scrambled sync signal that was coming and going on the screen. So that's why I hooked up the oscilloscope to see. Yes, and even though this picture is a bit grainy and somewhat out of focus, yes, there we can see better. We can actually see that the video signals is not looking all too bad. This should give us a signal, but we have 44 kilohertz frequency, and that does not compute with anything that should be video. I was supposing that this was meant to connect to a TV, and then it would have been the familiar 15600 frequency range for the video adapter. And you can also see that this is drifting somewhat. It goes from 44 kilohertz to 67 to 87, 77, and so on. So I think this will be it for this video. The circuit in itself works, but we really have to look into the oscillator circuit to see what's wrong there. It might be that the oscillator is starting on the wrong frequency, and that's something that can happen with these simple circuits. So thanks for watching. In the next video we will have to look into the oscillator circuit, and we will also check out the logic circuit and the clock signals for the CPU itself. So thanks for watching. Hope to see you again in another video, and please hit subscribe if you want to be notified when I post another video.